form to another form in after a few hours. In infrared, you get something like that. Again, no polyethylene, you can see, but this is another peak at 760 centimeters -1. And I think this is also, you can see over here also the crystallinity. That's over here, yeah. And yeah, as I've mentioned, it has also two crystalline forms. Probably we can see it also here on infrared, but this may be also interesting. If you have a material which is interesting, you can make different graphs and you can compare it and you can learn from it. But even I have to wanted to do something more in order to get more information. So then this is the graph, the temperature sweep of such a material. And again, you see a big difference of those two lines. The crystallization happens about at 110 degrees. That's normal. But that's also interesting. This is a temperature of the first crystal structure. This is also made by metallocene catalysts, so they can make a perfect type of polymer. The metallocene catalysts, the polymers can be reasonably short in length and still strong. I didn't do any DMA. That was maybe also a good thing that I could do to see what happens if I remain that particular material for more as a few hours, 2, 3, 4 hours in the DMA without heating it again. But I did here an DSC, which is another type of apparatus, and this shows you the enthalpy which is needed to melt something or to crystallize something. And you see over here an first melt of that material, which was already for more than 24 hours solid. So they had the second type of crystallizing, and it has here a melting temperature of about 125 degrees. And when you heat it, it melts, of course. Then you let it solidify once again at 75 degrees. And then if you melt it again, then you have the first form of the crystallites, which has only a melting point of 112 degrees. Yeah, just to be, I wanted to be complete. You have also polyolefin elastomers, where you have polyethylene parts with flexible parts in between, polyoctene, polybutene. Also made by a metallocene catalyst. The names are, for instance, Affinity, Engine, my God, I forgot, Fortify, and so on. Yeah. But you can see it also on the infrared machine, although you have to be look very closely. But here you see a small peak of the polyoctene, polybutene flexible parts. Okay. For the rest, it looks like just straight polyethylene. And again, this is then the DMA. At a certain temperature, it melts. Okay, now we have seen the olefins, and now I want to speak a little bit about the polyethylene vinyl acetate structure. What we can see on infrared and what we can see on DMA. So EVA is encountered a lot in a lot of products. EVA can be crystalline, or it can be, in fact, amorphous. And it depends on the amount of vinyl acetate. If the vinyl acetate amount is rather low, let's say lower than 45 or even lower, then it is crystallization is possible. And then, for instance, it can be used as in hot melt applications, or it can be used in thermoplastic elastomers and so on. Is it rather a high vinyl acetate, 100%, maybe it's also possible. Then it's rather encountered in dispersions. And there is a strange thing, and it's over here. If you draw